The most profound discovery of our time is that our universe had a beginning and that it's expanding. Yet the person responsible for this discovery is virtually unknown, and there's a reason for it, which will become clear. Georges Lemaitre was a Belgian priest who theorized that the expansion of the universe began with the explosion of a single particle at a definite point in time faster than the speed of light. The Big Bang theory is accepted by nearly all astronomers today. But back in the 1930s, the belief that the entire observable universe began with a bang was considered preposterous. Even Albert Einstein found it far-fetched. So how did Lemaitre come up with his theory? Let's go back to the beginning. Lemaitre was born in Charleroi, Belgium in 1894 to a well-off, devoutly Catholic family. He knew what he wanted to be when he was 9 years old, both a priest and a scientist. He grew up in a coal mining region, and at the insistence of his father, studied civil mining engineering at the Catholic Research University in the Belgian city of Louvain, only to have his studies interrupted when Germany invaded Belgium in 1914. He left university to fight as an artillery officer and received the Belgian War Cross for bravery on the battlefield. At this time, he was already thinking about the origin of the universe in the context of his Christian faith. He wrote to a friend while in the trenches of war, "I've understood the fiat lux as the reason of the universe." Fiat lux is Latin for "let there be light," in reference to the third verse in the book of Genesis. God said, "Let there be light," and there was light. After the war, he continued with his education, but switched to mathematics and physics, graduating in 1920. Then he went to seminary school and became ordained as a priest 3 years later. During this time, he became fascinated by Einstein's general theory of relativity, how gravity can warp space and time, which I talked about in a previous video. Lemaitre then did postgraduate work at the University of Cambridge under famed English astronomer Sir Arthur Eddington, who had confirmed Einstein's theory when he saw how gravity bent light from a star traveling near the sun. Eddington gave Lemaitre a glowing recommendation, after which he spent time at Harvard and then got accepted into a doctoral program at MIT. It was a good time to be in the US if you were a scientist, because of recent discoveries that shook people's understanding of the universe. Up until then, the Milky Way, which includes our solar system, was thought to be the entire universe, but more powerful telescopes showed this wasn't true. American astronomer Edwin Hubble announced he had evidence the Milky Way was one of many galaxies in the universe. He observed that the spiral-shaped Andromeda was in fact a galaxy. Another American astronomer, Vesto Slipher, noticed Andromeda was bluer in color, whereas other galaxies were redder. Slipher knew Andromeda was approaching us. Because if light is coming toward you, the waves get more squished, making the light bluer. If it goes away from you, it gets stretched out, making the light waves appear redder. The light of distant galaxies that appeared to shift more toward the red end of the color spectrum suggested they were getting farther away from Earth. The belief was that the galaxies were moving away in a static universe. However, Lemaitre interpreted this redshift differently. He concluded that the galaxies were not moving away from each other in a static universe, but rather the universe itself was expanding, which then stretched out the light waves.
Here's another way to look at it. Imagine that this balloon is the universe, and the dots the galaxies. As the balloon expands, then the separation between the dots also expands. And from the perspective of each individual dot or galaxy, it appears that the others are moving farther away from it.
An expanding universe completely shattered the notion that the universe was static, which is what Einstein strongly believed. But an unchanging universe was problematic for his own theory of relativity. If gravity were the only active force in a static universe, the universe would collapse. To get around this issue, Einstein added a cosmological constant, presumably a form of matter or energy that opposes gravity. On the other hand, Lemaitre's expanding universe would satisfy Einstein's theory of relativity. Still, Einstein wasn't swayed. He refused to believe in an expanding universe. Lemaitre recalled Einstein told him, "Your calculations are correct, but your physics is atrocious." It would take Einstein a long time to come around. He did finally abandon his cosmological constant, calling it the greatest blunder of his life. Lemaitre returned to Europe in 1925 to take up a teaching post at the Catholic University of Louvain, where he was formerly a student. In 1927, he published his case for an expanding universe in French in a Belgian scientific journal. This should have rocked the world, but it didn't. No one really paid any attention to it. It wasn't until 2 years later, when Hubble published his own findings about an expanding universe, that the world took notice. Hubble measured the distance of galaxies and also built on the work of Slipher, who had measured redshifts. He plotted the distance of galaxies and their velocities in this classic graph and showed that more distant galaxies were moving away from us faster than galaxies that were closer, and it made sense if the universe were expanding. This became known as Hubble's law. He came to the same conclusion as Lemaitre, yet Lemaitre didn't get any of the attention and accolades bestowed on Hubble, because Lemaitre had published his findings in French in an obscure Belgian journal that wasn't widely read outside of his own country. His mentor Eddington is said to have helped arrange an English translation 2 years after the release of Hubble's work in 1931. However, the paper omitted Lemaitre's crucial paragraphs describing Hubble's law. Turns out, Lemaitre chose to leave this out himself. He reasoned that Hubble's calculations had already improved on his earlier work. He apparently wasn't fussed at proving that he had come up with the expansion theory before Hubble. He was a humble man who didn't mind that Hubble got the glory. Instead, Lemaitre moved forward with his research and published a new paper in 1931 in which he argued that if the universe were expanding, then it also had a beginning. He proposed this in his hypothesis of the primeval atom. A primeval atom was a single particle. He argued that the universe began with the explosion of the single particle that gave birth to our entire cosmos, and concluded a creation-like event had occurred. Researchers date the event to more than 13.8 billion years ago. He didn't call it the Big Bang. Astronomer Sir Fred Hoyle coined the term during a talk broadcast on the BBC. Hoyle actually thought the theory was nonsense. Many scientists were skeptical, including Einstein. However, in 1933, when Lemaitre and Einstein traveled together to attend a series of seminars in California, and Lemaitre had time to explain his theory in detail, Einstein is purported to have said, "This is the most beautiful and satisfactory explanation of creation to which I have ever listened." Lemaitre was nominated for the Nobel Prize in Physics in 1954 for his prediction of the expanding universe. 2 years later, he was nominated for the Nobel Prize in Chemistry for his primeval atom theory. He didn't win either. The strongest evidence supporting the Big Bang was discovered by accident a decade later, in 1964, by American scientists Arno Penzias and Robert Wilson, who were working for Bell Laboratories, the research and development arm of what is today Nokia. They were baffled by a strange signal noise picked up by this antenna and tried to figure out what it was. They even removed some pigeons that were nesting there. That's when they stumbled upon cosmic microwave background radiation, ancient light thought to be left over from the Big Bang. Lemaitre lived to see the moment of their discovery. His ideas were finally vindicated. He died 2 years later, in 1966, from leukemia at the age of 71. Despite not being as arguably well-known as his fellow scientists, he is finally getting more recognition. In 2018, the Hubble law was changed to the Hubble-Lemaitre law. Lemaitre may have helped uncover the secrets of the universe, yet the more we learn, the stranger it gets. Scientists thought that the expansion of the universe would gradually slow down over time as gravity put on the brakes. But surprisingly, they found the opposite. Turns out the expansion of the universe is accelerating. Some mysterious force is driving our universe apart, and we don't know why. Perhaps in time, this mystery will also be solved.
همراه با علم، مجله علم روز science today.ir